All right, so the first thing, everybody, we had lecture on Monday, so you do have lecture questions whenever we have a lecture. So hopefully you did those. And then today we are going to do your weekly participation points. So we're going to make sure that everybody is getting those done for the 10 points for the week because you came 2 days this week. All right, a couple other things. You do have your quiz like you have every Friday. And on Wednesday, we talk about what it is. It's open from 7:30 until 1:30. It's going to be 13 questions. Okay, Wisconsin. It's going to be 13 questions and 30 points. Cosmos, did you take the PSAT yesterday or no? Awesome. Okay, so it's going to be over bonds, which what we talked about on Monday. And then today we're going to talk specifically ionic bonds and naming binary formulas and writing their compounds. So everything that we do today, I know we don't usually have lectures on Wednesdays, but because we didn't lecture yesterday, we have a lecture today. Monday and today's stuff are going to be on that quiz on Friday. Okay, perfect. So let's get into it. The first thing that you have in your packet is I do want to remind you of what we did on Monday. So go ahead and turn to where it says atomic or chemical bonds, bell work. Chemical bonds, bell work there. This is going to refresh what we did on Monday. The first one says, please go ahead and write the full electron configuration for the element and then circle the valence electrons. Remember, the valence electrons are the only ones we're going to use in bonding. So if we are using our periodic table to write for nitrogen, you would write 1s2, 2s2, and 2p. How many do we got going in there for nitrogen? 2p. Yes. 2p for nitrogen, 1, 2, and 3. So 5 total. I know what you're saying back there. I gotcha. And now remember, it says if you are going to circle the valence electrons, the one on the highest energy level, which ones are you going to circle? The ones with the 2 in front of it. So we're going to circle the 2s2 and 2p3. Correct? All right, I want you to do the next two. Then I want to know if any of these are stable and why. You might want to think about the octet rule. Then, with your periodic table that is labeled, okay, you should have the valence electrons and their stable charges. We did that on Monday. Number 3 says how many valence electrons are present. Okay, so that's the group number itself. And then number 4 is what is the most stable charge. Okay. And then this is all the information. How many valence electrons do they want? That's that octet rule. So go ahead, use your periodic table, answer a few of these. I'm going to come around, see how we're doing. And then we're going to move forward into the new information today. So I'm going to put the music on quietly, see how it's going. Perfect. You have your charge on here. So this is valence electrons. Right? And then this is the charge. Those are going to be the numbers on the top of the row. Okay. Go how to read these out. Okay, you wrote that much in the way that was in the last minute. That's how you go. Argon is over here. Does he react? He's in a noble gas. So I know you were doing your perfect. That's the answer to that. And then here, so I wrote 1, 2, 3, 4. So this one talks about the valence electrons. And this one talks about the charges. Yep. 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 And then that one is just the charges that you wrote on Monday. So orange. So yeah, so you're kind of perfect. You're good. Yeah, okay, so you were in WDA. So let's not worry about that. Let's just go from there. Yeah, so what you need to do is talk. Yeah, perfect. This one's going to be both. Okay. Very good. Good. So valence electrons are the electrons from highest energy level. You see you wrote those here? So 1 has how many valence electrons? Very good. Chlorine has how many valence electrons? Yeah. And then remember on Monday, we wrote those charges on the top. +1, +2, +3, +4. And so when this says stable charge, we know what it is. How do we do this?
Yeah, we'll get the blocks.
Got it.
So is that this side?
Awesome. All right, let me help you with a few of these. The electron configuration was from the last unit, so if you want to go through those, we can go through those quickly. All right. The next one, you should have 1s2, 2s2, 2p6, 3s1. That is your valence electron. Remember, you can always check yourself. Sodium is in the first group, so it does only have one valence electron. And then you got argon. Let's talk about argon while I'm standing here real fast. If I circle 3s2 and 3p6, how many total valence electrons does that give argon? 6 and 2 make how many? 8. Okay. And so we said per the octet rule, how many valence electrons does every element want? 8. So is that one going to be stable? Absolutely. So for number 2, yes, argon is stable because his third energy level is completely full with a total of 8 electrons. Awesome. So now I want you to focus on 3 and 4 and 5, which we kind of just answered number 5. And then we will see you back here so we can do the notes here in a second. Can you do the rest 3 and 4 and 5? Anybody at home have any questions so far? Alex, you doing okay?
Yeah, I'm doing fine.
Awesome. Stick with me. Mariah, talk to me. Are you doing okay?
Yeah, I'm good.
All right. Kayla, talk to me. Are you doing okay?
Yeah, I'm good.
Patty, talk to me. Are we doing all right?
Yep, I'm good.
And Patty, I saw that I don't think you did the lecture questions from Monday. You probably just forgot. So while we're kind of just chilling here, if you're done with the worksheet, go into the Monday folder. Make sure you get the easy 6 points, okay?
Okay, yeah, I forgot about that.
Thank you. All right, let's see some number of valence electrons and some charges. Good, good. Get the number. Here, oh, you were here on Monday, right? Why didn't I write our pluses and stuff like that? So remember, everything in group 1 is going to give away that electron, become positive 1. They're going to all become positive 2, positive 3, and so I'm talking about everything in the group. These can either give them or take them. He has 5 valence electrons, so he's going to gain 3 more, so he's going to be -3, 2. And so everything in that, just like with the valence electron, everything in that group will have a -1 charge. Okay? Perfect. So number 3 says valence electrons, so you're looking at your right. This one says stable ionic charge. So that's going to be perfect. Talk to me.
Six. Yeah, all the way through. 386.
So you can go back and I have everything in this blue first semester 1. And so this that particular thing is in unit 5, which is what we sent right before you came. So going to the Fluency, unit 5, and I have all my lectures up until that next. Perfect. Talk to me. This is number of valence electrons. This one's just going to be 3e. You with me? Perfect. Nice. Good. Nice on the chart. So this one is the number of valence electrons. So that's going to be your. Remember, this has 1 valence electron.
Yeah.
2 valence electron. 3 valence electron.
Practice. Used to the sequence. Right. So try
This is from the last unit.
Okay.
Remember, helium is the only one. He only has 2 valence. Perfect. Awesome. Good. So you're just looking at the purple number for that one. I love this. I love this right now. And then for number 4, you're looking at your orange number. Okay. Perfect. Awesome. So you know what you're doing here. Good. It is. Very good. And then the charge is the one that we wrote on Monday that's on the top of that. Okay? Perfect. You guys are doing great. Yes, Doctor. We are. So it's perfect to me. Argon is neutral. Lithium is +1. You're doing great. You did great. Very nice. Perfect. Good. And so the charges that you added on Monday, you wrote that in.
What happened?
Awesome. Yep, that's good. Okay, right. Now here is going to be this chart that you wrote on Monday. The top of it, okay?
Yep.
Perfect.
Yes. 2. Same sequence. So 1
Yeah.
2 here, 2s2 there, 2p6 here.
Yeah. If you want to write, you can write 1, 2, 3, 4, 5. Put it on the side. Okay. There you go. No problem. Perfect. All right. Hopefully we are on our way. Getting ready to move on. We've got to learn how to name some binary compounds here. Cameron, you are here? So we were just missing Logan.
Okay, now I'm available.
All right, are we all tapped down on the bell work? Let's move it along, should we? All right, so hopefully all of you at home got that. For the first, or number 3, I guess I should say, you should have 3, 7, 2, 6, 8, and 1. For the next row, you should have 2, 6, 3, 5, 4, and 7. Those are the number of valence electrons. Remember, that is just correlating exactly with the group number itself. Then on Monday, we talked about how to figure out and predict the stable charges, and we wrote them on the top of our periodic table in green on mine, whatever you wrote them in on yours. So those charges here should be 0 for argon, remember, because he does not react, +1, +2, ±4, +2, -2. And then you should have +1, -2, -1, +3, -3, and a +1. Anybody have any questions on where those numbers came from? We need to use those today. And then the octet rule, everybody wants 8 valence electrons, except, you know, there's always an except. Hydrogen and helium are happy with 2. Feeling good? All right. Perfect. All right, so turn it over to the next page. We are going to learn how to do binary naming, and then I'm just going to let you practice, and we will be done for the day. All right, you do want your periodic table near you? Let's get it going. This will be on your quiz on Friday. Like I said, I know we don't usually lecture on Wednesdays, but you guys said had PSAT yesterday. I want to take a very quick moment because I have found over the years that sometimes students kind of by this point forget the matter unit and what the difference between an element and a compound is. Remember, an element is what you find on the periodic table. Does anybody have a favorite element? Think of one element you can name. Carbon, beautiful. Okay, oxygen, chlorine, anything directly off the periodic table. So whatever you want. Okay. Now, when you make a compound, which we talked about on Monday, you have to transfer some electrons or share some electrons, and they come in a combination of elements. So when I say, hey, name this compound, or hey, that compound, we are talking about a combination of elements that have come together. And remember, they always get a new set of properties. Okay, so just hitting this, we hit this a few times in the matter unit. We hit it again on Monday, but just to remind you one more time, we were talking about elements that are coming together. Now they have a new set of properties. For instance, like water or carbon dioxide or salt. Okay, hydrogen's a gas, oxygen's a gas, but when they come together, now they're liquid at room temperature. Okay, so we're talking about compounds today. This is what we are talking about today. All right, so in order to make one type of compound, we're going to do what's called an ionic bond. In the spring, you guys will talk about covalent bonds, but everything in our world right now is going to be an ionic bond for right now. An ionic bond is formed by the attraction, okay? So if you think of like magnets sticking together, they pull each other together with an attraction of oppositely charged ions. They are formed by the attraction of oppositely charged ions. So that means we need a positive something and a negative something. Correct? And you guys remember from the last unit, we said that the metals over here always tend to become positive. And now you guys know exactly their positive charge. And over here, they tend to become negative. So what that's going to tell us is when we have an ionic bond, okay, more often than not, it's going to be between a metal, which is positive, and a non-metal. So you pick one from the left and one from the right, and if they react together, that is an ionic bond. Okay? You might see that on your quiz, asking what elements are involved in ionic bonds. One from the left, one from the right, because you need a positive and a negative. Okay, so we're going to kind of show you the steps on how an ionic bond would be made. Okay, and it's hard to do on a flat piece of paper. We're going to try our best. Let's go ahead and fill in some information about sodium, shall we? So we find sodium on our periodic table. What is the atomic number for sodium? How many protons does he have? He has 11 protons. And before he does any reacting, he is an atom, so he is neutral. So how many electrons would he have to have? Very good, also 11. Okay, remember, in the first energy level, you can only put 2. So let's go ahead and draw 2 electrons on the first line. 1, 2. Okay, and this is kind of doing what we were doing on Monday. In the second energy level, we can have 8. So in the second ring, let's draw 8. 1, 2, 3, 4, 5, 6, 7, and 8. Now, I will not make you draw all the electrons all the time because that is cumbersome and annoying. But we really want to make sure you know that elements have lots of electrons, not just their valence electrons. We're going to stop talking about these and focus more on the valence. But I want you to remember there's more electrons in there. Okay, so that gets me 2 and 8 makes 10, but I need 11 electrons. So I'm going to put 1 more electron in the outermost energy level. That is sodium's valence electron. That is what he can bond with. Okay, perfect. Have we all set up sodium? Let's set up, we want to see chlorine over here. How many protons does chlorine have? Chlorine has 17 protons. Oh, so to get to 0, how many protons or electrons will we need? You got it, 17. First energy level can hold 2. So let's do it. 1 and 2. The second energy level can hold 8. 1, 2. This one's going to be a big one. 3, 4, 5, 6, 7, and 8. So that got me to 10. To get to 17, how many does chlorine have in its outermost shell? I only have 7 more. And if you want to check yourself, you're like, hey, does he really have 7 valence electrons? Let's see. Chlorine, 7 valence electrons. Yes, sir. Oh, heavens. All right. So 1, 2, 3, 4, 5, 6, and 7. All right, so I'm going to highlight mine a little bit so we can see them. I want to show you just the valence electrons. 1 here, 1, 2, 3, 4, 5, 6, 7. All right, so now we're ready to make an ionic bond. Are you ready? So I have some steps below, and then we're going to alter this drawing up here. So the first thing that happens, does sodium want his 1 valence electron? No. He says, you know what? I'd prefer not to have it. Thank you very much. So what he's going to do is he is going to take this 1 valence electron and get rid of it. And what that effectively does is that takes away, oh heavens, that entire ring. So now he has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Is he happy with 8? Yes. Okay. So the first thing is electrons are either given, which that's what sodium did. He gave away an electron. Chlorine has 7 valence electrons. What do you think he's going to do if he sees one hanging out? He's like, sure, buddy, I'll take that electron. Or they're taken so that they can become stable. Now, this is all happening simultaneously. As that happens, though, we got to talk a little bit of math. If I used to have 11 electrons and now I have 10, what is my charge? Is it still 0? Plus 11 minus 10 is how many? Positive by how many? 1. Very good. Okay. So as soon as I get rid of that electron, he is stable, but now he is a +1 charge. Okay. Chlorine over here gained an electron. So he is going to become negative by 1. So the second step is that they become charged, oppositely charged ions. So when you give, you become positive. When you gain, you become negative. And now, you guys know the saying, opposites do what? Attract or repel? Opposites attract. So as soon as they have oppositely charged ions, they are now like magnets. They are stuck together. They are attracted to each other. And what that attraction is called is it's called an ionic bond. Okay? Awesome. So you have to give or take an electron, set up your charges, boom, now you are attracted together. And there's a couple kind of little videos I have here. This is the one we just did. Sodium gives his yellow electron over to chlorine. And then as soon as they do that, they set up their charges. Now they have an attraction. Okay. This happens with any metal and non-metal. Sodium can give it to fluorine, and then they'll set up their charges, and they can be attracted together as well. Okay. This is called an ionic bond. Feeling good? Awesome. All right. So now what we're going to do is we're going to learn how to write, but I want to just refresh one thing very quickly because it's important now, and we will start marking things wrong if you don't do this. When you're writing a chemical symbol, you have to capitalize the first letter, but the second letter is always lowercase, okay? The second letter is always lowercase. So oxygen is just O. Once you get to something like chlorine, this good old days of Cl like that, no, okay? Second letter has to be lowercase. Magnesium. People are like, yay, here's magnesium. No, lowercase. And you will really start to see the confusion if you don't follow the rule between titanium and thallium. Okay? So make sure you lowercase the second letter all the time. All right, let's do it. We're going to talk about how to write formulas first because it's the more challenging of the two things we're going to do today. The rule 1, when you're writing the formula, your positive metal goes first. Your positive metal goes first. It's usually the metal. Your positive metal goes first. Then you'll put your anion. But the biggest thing is once you write these, and this is going to be the rule from now until the end of time. The total charge must be neutral whenever you're writing a formula. The total charge must be neutral. If you're writing a formula for a compound, I don't care if it's today, Monday, whenever, they have to be neutral, okay? If you need more than one of something, you write a subscript after the element you want. You guys know how to do this. H2O. What is that 2 talking and telling me I have 2 O? Is that 2 talking about the oxygen or the hydrogen in water? Do you know? The 2 is very good, okay? So if you want 2 of something, you put a subscript and connect it to whatever element you're talking about. Let me show you. So the first thing you always want to do, you need your periodic table. Ready? We got to look at the charges of what elements are involved. Can somebody tell me the stable charge, the last one we wrote on Monday, the top, what's the most stable charge of calcium? Perfect. And what is the most stable charge for sulfur? Perfect. Now, does +2 - 2 equal 0? Yes. So the formula for calcium sulfide is just CaS. Okay. Now, this is a little bit different. The most stable charge for magnesium is +2, but the most stable charge for chlorine is a -1. If I wrote MgCl by itself, is that neutral? +2 - 1, is that neutral? No. What do I need another one of? I need another chlorine. So we're gonna draw this out and slow this down. If this is confusing, that's okay, but we're gonna get there. But as you can see, I need 2 chlorines. Your positives have to equal your negatives. It's not always the second one. It might be, for instance, it might be the first one. Hydrogen is a +1. Nitrogen is a -3. +1 - 3, is that neutral? Okay, are they equal? No. I need 3 hydrogens to neutralize every 1 nitrogen. Okay, and we will practice this, but this is on your quiz on Friday. All right, let's do the last little thing in the notes, and then I'm going to turn you guys out to practice here. Naming is extremely simple. All you have to do is add 1 suffix. Okay. When you are naming, number 1, again, the positive ion goes first, and it's more than often the metal. Hydrogen is your only exception on that one. So this is if we're naming them. When you write the first name, you write out the full name, like hydrogen, calcium, barium, sodium. The whole name. For the second ion, though, you're going to put the negative ion. It always goes second. That's usually your non-metal. This is the formula for salt. Does anybody know it's called sodium what? Have you ever heard of this? Salt is called sodium chloride, right? So you guys know this rule already. What you're going to see is that the second name always ends in an IDE ending. So you're going to have sodium chloride, oxide, fluoride, sulfide, bromide, nitride, phosphide, iodide, carbide. I put those on your paper for you. And you want to know what I did on my periodic table? I personally wrote IDE really big up at the top. So I know if I'm naming any of these guys over here, they have an IDE ending. So again, you can write that for yourself on your periodic table if you would like. Okay. Awesome. So let's just talk them out because I know you guys are probably annoyed of writing here real fast. So this is sodium chloride. Can anybody think of the name of the next one? What is Ca? Calcium bromide. Okay. The next one would be lithium Oxide. Very good. Then magnesium fluoride. Now, remember, you write the full first name. So what is H? Hydrogen nitride. Very good. And then strontium iodide. Okay. So whenever the second letter, the second name has an IDE ending. And I went really fast. You guys don't have to write all those if you don't want. So we're going to get ready for your practice, and you do need your periodic table out. There are what we call visuals in this unit. You will also draw balancing equations. You will draw a couple different things. When we talk to some post-secondary teachers, they say, yeah, it's nice if they can name it, but it's even better if they can see what's going on. It's actually a higher level of understanding if you can draw it out and kind of see how things come together like a puzzle. Okay, so while you might think drawing is like super easy, it's actually showing me a higher understanding on this next worksheet, okay? So let's get to that. Boom. Periodic table ready. I'm not going to do the first couple questions because that's just easy from your notes. Let's start with the first one. As soon as you see two elements coming together, the first thing you should want to do is look up their charge. So grab your periodic table. What is the charge of lithium? Lithium. Yep, +1. And oxygen is a -2. Thank you. Very good. Okay. So now we need to see you draw it out. Okay. Draw yourself a lithium, Li +1, and an O -2. Physically draw that out. Now, Li is a +1, O is a -2. Is that neutral? No. What do I need one more of to get to be +2, -2? We need one more lithium. So this is almost exactly what you guys were doing on Monday, just with charges instead of drawing the electrons. So now when you go to write your formula, it should be very simple. I need Li, how many of them? Li2, and then how many oxygens? 1. Okay. Li2, O. What would be the name of this? We just write what we see and put an IDE on the second one. This is lithium. You got it. Okay. There's one hard one at the bottom. We're going to see if you can get to it. I'll do one more with you, make you do one by yourself, and then we'll see if you can do the hard one. Boron and fluorine, when they react together, what is the charge of a boron? +3, thank you. Fluorine, -1. Awesome. So let's draw it out. I'm going to have one boron as a +3. And what if I have one fluorine? Is that neutral? No. How about if I have another fluorine? Is that neutral? Nope. Another fluorine. Now I have +3, -3. And so my formula is going to be what? B, 1B, and how many Fs? You got it. Can we name it? Boron fluoride. Awesome. Very good. All right. I want you to do the next one by yourself. And this one, I'm going to go over with you. It's quite challenging. Let's see if you can't figure it out. Remember, they always have to equal to 0. So good luck with that. I'm going to walk around and see how we're doing. Hopefully those of you at home are doing okay. Anybody at home have any questions before I walk around? Oh, Nick, hey. Good to see you back. +2. So the orange number that we're looking at. And chlorine is that's what I'm talking about. Very nice. Oh, I see you getting the hard one. If you write the charges, sometimes it helps you. So write +3 here. Yep, -2, -2. Now, does that equal each other? So let's add another aluminum. And now I'm +6, right? What if you add one more oxygen? Would that be a total of -6 then? Very good. So it's going to be Al How many do you see? And O, how many do you see? Beautiful. Very good. That one's a tough one.
Good.
Magnesium is in charge of what?
Because you need two, right?
Okay.
So
And
now,
plus two here. What's in charge of chlorine? Yep. So it's like Mg plus 2,
are you talking about the
Cl
right?
minus 1.
So
Is that neutral?
write it just as you see it. So
Plus 2 minus 1. Does that give me
FG,
0?
how many FG?
What do I need?
Wait, how do you just one? Because it's a plus two.
What do I need more of?
So you just write out FG.
Figure out
You
what it
guys.
is.
Yep, so I need one more
CL.
CL.
That's how to name it.
I'm sorry, my
So first stays the same. Second
now
you
this
just
is
change it to
totally-
IDE.
negative 2 on this side, positive 2 on that side. Does that equal 0? Good. MgCl.
Magnesium.
Now,
How you doing? I was just going so fast. so you
Right.
don't have
Yeah,
to
yeah.
just watch
so
it.
it's a little
Yeah,
different
good.
like
Please do. I think that's a fantastic thing.
I can't.
Okay, you guys out. Oh, he's gonna be my long-term stuff. I kind of introduced him. Yeah, right. Tuffy. Add another oxygen. Let's see what happens.
Okay.
Still not balanced, huh? Let's add another aluminum.
This
Yeah.
one stays the
You're
same.
eventually gonna do it. I see what you're going here, but let's add this aluminum here. So now I'm up to plus 6, right?
So the first one
Hey, but
is
if
the
you
same.
add that oxygen like you were gonna do over there, then is that minus 6? It is, perfect. It's just you have to go back and forth a little bit. Nice. All right, good luck with that one. It's a hard one. You're gonna get it though, I know. You can do it.
Be chlorine.
No, you can.
It's gonna end in IE.
Okay, here. So this is plus 3.
Yes, there you go.
This has to be a minus 2. You can't change it. So let's make that a minus 2 real fast. But it's not neutral. I know why you made it a 1, right? Because it's not neutral.
Two ALs.
Let's put another aluminum over
Plus
here.
6.
Al plus 3.
Well, what's oxygen?
Good.
Minus
Then, so this is now plus how much?
There's only one of those.
This next one, really?
And this is
Plus
only
6
minus
doesn't
2.
equal
But what
minus
if
two.
there's
Sorry.
another
Well, no, you're good.
oxygen on there?
You're
Because
good.
it has to be plus or minus 2. Now, is this
Yep.
plus 6?
Yeah.
Minus 6? Boom. So what is the formula? Al2O3. So just go ahead and choose that. That's awesome. All right, so I think I'm seeing everybody here. So I'm doing this more for the people at home. Hopefully you guys at home are doing good here. If you're in here and you're rolling, you keep rolling. Plus 2 minus 1. So the next one is MgCl2 for those of you at home. Hopefully that you got that. Now, those of you at home, like I said, I think everybody got this one done. Let's see. For aluminum, it's a plus 3. For oxygen, it's a minus 2. You got it. Very good. So you probably went through and you said, all right, Al plus 3 and a little oxygen minus 2. That is not 0. Okay, I know what to do. I'm going to add another oxygen. Minus, okay. Well, now I've just messed things up because now I'm plus 3 minus 4. Well, I have to add more positives. You cannot change the charge. That's the way that it comes, okay? And so we got that there. Well, now I'm not balanced either. If we add one more oxygen, though, now this is positive 6, and this is negative 6. So what you can see, when you see these numbers here, what do they both go into? They both go into 6. You'll eventually know you need to make them into a charge of 6. So what do I have here? I have how many aluminums? 2. How many oxygens? 3. And that is aluminum oxide. Okay. So again, very simple. Another thing that I want you to see, if you flip it over on your quiz, because you can't really draw like that on your quiz, you're going to see them more like this. Okay. Remember, when you are naming, you just write, I would write right here with an IDE ending on the second one. So hydrogen bromide, aluminum fluoride. Now, the only problem is people, as soon as I don't make you draw them out, you're like, yeah, these are so easy. Look, it's just ALBR. Done. That is wrong. Whenever you write a formula, it has to be neutral. So aluminum is a plus 3, bromine is a minus 1. Can anybody figure out this formula without drawing it out? It's going to be ALBR3. Okay. And we're going to practice that again tomorrow. Thank you guys very, very much. Your quiz on this is on Friday.